Now the third use of the dummy variables, both for slope as well as intercept over time. We make, suppose, of the two, we make use of the same attributes, the two different attributes. Suppose there is lockdown days and no lockdown days, and that is indicated by your dummy variable d1. So we are saying like what, your, we want to check actually whether your expenditure is being affected by the two different attributes or not, in terms of both slope as well as the intercept term. So when you try to check whether there is any impact on these two different attributes on your expenditure, we have to be very careful, like in including your dummy variables. So what we did here is, suppose beta naught plus b1 d1, this will indicate this d1 will be made use of for your intercept term. That means beta naught plus b1 d1. Remember, I have not put any variables attached to this. Now in your second equation, beta 2 income plus beta 3 income d1. So this d1 indicates we are making use of the dummy variables to check whether there is any impact of these two different attributes on your income or not. So that's how we have to be smart enough to include the dummy variables in our multiple regression model. Here we have included dummy variable 1 for the intercept term, and this dummy variable d for the another independent variable to see the changes, whether there is any impact or whether our expenditure is being affected by these two different attributes on the intercept as well as the slope or not. Now when you estimate this equation, if your d1 is equal to 1, then what you get is, if d1 becomes d1 is equal to 1, then automatically beta naught cap plus b1 cap, so d1 becomes 1, right? This d1 becomes 1, so it will be beta naught cap plus beta 1 cap. Now for the same thing for the another independent variable including the dummy variables. So what we get is, when we estimate this beta 2 cap income, we get beta 2 cap. Now when we estimate this another variable independent variable income with including the dummy variable, what we get is beta 3 cap, and so it becomes beta 2 cap plus your beta 3 cap income. Now another suppose your d1 is equal to 0. Now if your d1 is equal to 0, what you get is expenditure is a function of, or a estimated value of the expenditure is beta naught cap plus beta 2 cap. How is it coming? So if this d1 is equal to 0, then your beta 1 also will be 0, right? So this beta 1 gets deleted. That's why we have not included it here. Now again, the for the income variable, if d1 becomes 0, since we have put it d1 is equal to 0, so what we get is your beta 3 cap gets deleted, and what we have is only this beta 2 cap income. So that's how we can estimate. Like, now we can understand this from also from this diagram like this. Like, we want to check, we are checking for both the slope as well as the intercept. So this will represent the changes in the slope, that is 1 for beta naught cap plus beta naught plus beta 1 cap, means there is a change in the slope. That's why there is this is increased to beta naught cap plus beta 1 cap, and the other one, that is beta 1, this slope is changing, that means we can indicate that with, we are indicating that one with beta 2 cap plus beta 3 cap. So here it is only beta 2, right? So we can indicate the changes in the slope or the increase in the slope during the normal days or during the no lockdown days, all right? So that we can be represented with beta 2 cap plus beta 3 cap. And similarly, this will indicate for the change in the intercept term, and this will indicate for the lockdown days minimum expenditure, and this will represent the minimum expenditure during no lockdown days, and this will represent for what, the change in expenditure due to change in income or the slope during the lockdown days, and this will represent what, change in intercept, or sorry, the change in slope or the during the no lockdown days. So generally we can understand this way, or we can make use of the dummy variables in our multiple regression model. Well, lastly, dummy variables may also be used to check the structural break in a time series data set. Uh, well, suppose we consider two different time periods again. Suppose say from the month January to July, we take it to be the normal days, and suppose say August to the month of December, we consider it to be the lockdown days. So based on these two different attributes, we can make use of these dummy variables. We can make use of these dummy variables to check whether there is any difference over a period of time in our intercept as well as the slope. You can use it anywhere. Here I am doing it for the change in intercept. How we can identify this? Because I have not included this dummy variable, the d1 variable for the I have not included it for checking the slope, whether there is any increase or decrease in the expenditure over time or not. Here I am just checking is whether there is any changes in the intercept term or over a period of time or not, by making use of these dummy variables. So generally when you estimate this equation just by taking d1 is equal to 1, we are talking about, suppose say, about the normal days. During the normal days, so what happens to our expenditure during the normal days over a period of time? Since we are talking about the time series data, then what happens to our expenditure, expenditure during the normal days? So that can be represented by this equation, that is expenditure is equal to beta naught plus beta 2 cap. See, look at this carefully, beta 2 cap. How? Because I have put this d1 is equal to 1 for the normal days. So this beta 2 cap is coming from d1 is equal to 1. So it means like what? During the normal days, there is a increase in your minimum expenditure. Now during the lockdown days, so if there is a lockdown, so I have included this d1 is equal to 0. So if d1 is equal to 0, for this equation d1 is equal to 0, your expenditure estimated value of this regression equation is beta naught cap plus beta 2 cap over a period of time. So this beta 2 cap becomes 0. That's why we just get this beta naught cap plus beta 1 cap. So similarly, we can understand this from the diagram that I have put for the previous examples as well. So we can say like expenditure is changing over time or not. So that's what I was trying to check. I was trying to check for this the intercept term alone, not for the slope. So look at this line carefully. So it looks parallel. That means there is no change in the slope. This both the slopes are the same. So since I'm not talking about the changes in the slope, I'm just talking about the change in intercept. You may use it both for the slope as well as the intercept for checking the structural break in a time series data. But just to make it simple, I've just shown you whether how you can make use of the dummy variables to check whether there is any changes or the structural break, or we call it whether there is any difference between these two different intercept terms or not. So during the normal days, this d1 is equal to 1, this beta naught cap plus beta 2 cap. So it is beta naught cap plus beta 2 cap for the normal days. And during the lockdown days, since there is less expenditure over a period of time, or there is no increase in your expenditure if d1 is equal to 0, so what you get, the equation is beta naught alone. So there is no change in the intercept for this nor during the lockdown days. Anyway, we can make use of this dummy variables for structural break for two different purposes, or for both the purposes, like the one I have shown for slope separately and intercept separately. But you can combine it both also, like whether you want to check it for both the slope as well as the intercept term. So that's what how we make use of the dummy variables in our multiple regression model. That's all for today again, guys. Thank you.